So today the lecture is going to be about enzymes. It's SB1B, explain how enzymes function as catalysts. We talked about catalysts a little bit in your graphic organizer on the macromolecules. So enzymes are special proteins. They're catalytic molecules. And basically a catalyst means that it's going to speed up a reaction and it's not going to be used up in that reaction. This is a molecular picture of an enzyme. Some common features is that enzymes don't make reactions happen. They speed them up and they aren't altered in that reaction. Enzymes can work forward or in reverse directions, and enzymes are highly selective to its substrate. I think of an enzyme as a lock and a substrate as a key. So basically a key can lock and unlock a door. A key can lock and unlock a door. And it also provides easier entry into a door. Yes, the door could be open if you kick it in, but it would be a lot easier and using less energy if a key was used to unlock it. So this is a picture of how the mechanism of the enzyme works. It's called the enzyme substrate complex. Basically, the lock and key mechanism is what I just explained. The lock is the enzyme itself, and the key is the substrate. Together, they make an enzyme substrate complex, which is this right here. When the two fit together, the enzyme will unlock the product, and out comes two. So they can work in both directions. So we have the substrate here, and it goes into the enzyme. Notice the shape of the substrate is particularly complementary to the shape of the enzyme at the active site. Then the enzyme substrate come together, and what basically happens is the substrate bonds are broken within the enzyme and two products are released. It also could work in the reverse direction where two products will go into an enzyme because they're specifically shaped that way. It forms an enzyme substrate complex, and then the enzyme are going to bind the products together to make a substrate. Now, we talked about temperature and its effect on diffusion. It has the same effect on how enzymes work. Temperature can affect the speed. So the higher the temperature, the faster a reaction can happen, and the colder the temperature, the slower a reaction can happen. Now, denaturing of an enzyme basically happens when an enzyme the temperature has been raised so high that it ruins the enzyme and it becomes denatured. Denatured means the shape of the enzyme is not conducive to be working anymore. Almost like when a lock is stripped. You can't use the key to get into it anymore. So that's what happens when an enzyme is denatured through high temperatures. So the amount of activation energy. Activation energy is the amount of energy it takes for a reaction to happen. And what enzymes do is it lowers the amount of activation energy required to make a reaction happen. So these pictures, it says with an enzyme, it's smooth sailing. Without an enzyme, this amount of activation energy is very high before the reaction can happen. Think of it as going for a drive. The more activation energy required, the slower the reaction time. Basically, if you're driving up a hill, you're going to push the gas down really hard, and then eventually you'll reach the top and be able to sail down the hill. But if you have enzymes, it's almost like not having a hill at all. The energy is there. You don't have to push the gas as much, and you get to that same place really quickly. Okay, so let's see how they work. All right, some things that are going to affect or denature an enzyme is going to be the high temperatures, like I talked about before, extreme pH, and pH is the percent of hydrogen ions. Basically, things with a high pH or a very low pH are not normal. Acids and bases, we're talking about lemon juice, battery acid, anything that has a really high, extreme pH, extremely high or extremely low, can denature a protein. Okay, so let's look at how specific an enzyme is. So we've got two different enzymes, and we've got two products that need to be worked on. This is a double sugar, so it would represent a carbohydrate. And once they break these apart, then they would be glucose. So let's see which one this one will go into. Okay, it does not fit because this shape might, but this one does not. And the enzyme is specific to its substrate. And bam, that one is a perfect fit. And now it can be broken apart into simple sugar molecules like glucose. All right, let's try another one with the opposite. They're separate, and let's see if we can join two simple sugar molecules together using an enzyme. Perfect fit. This one fit into this active site, and this one fit into this active site, and that makes a full bond, a double sugar. Now let's look at reusing enzymes and how we can build these polymers using only monomers. So we've got a lot of these small molecules. Let's say these are little amino acids, okay? And amino acids are going to join together to make protein with the help of an enzyme. All right, so we've got these molecules, and there's a bond, and here's an extra subunit. It does not fit into the two active sites, but we can solve that problem. So basically, the enzyme is forming a chain and being reused over and over, and in the end becomes a polymer. So if we started out and these were amino acids, then they were joined together to make a polymer, which would be protein. Now let's talk about denaturing, and that's the last part. So denaturing is, like I said before, exposure to extreme heat or extreme pHs that's going to change how the shape of the enzyme. So we've got a normal situation where the enzyme bonds with, helps bond the two substrates, and they go away. Now let's see what happens when we add extreme heat. Okay, notice how the enzyme shape changed, and these substrates aren't going to be able to fit into this specific enzyme because of the extreme heat. Now it does not fit. The small molecules, they can't react, and they won't be able to find each other. All right, enzymes only speed up reactions. These reactions are going to happen already. They can happen, but with the help of an enzyme, it actually helps speed it up. So without an enzyme, let's look at the example. We've got these simple sugar molecules, and those two black lines are supposed to meet in order for the bond to be made. Now, it took a lot of bumping around and a lot of colliding, and it did not meet up. Now let's see what happens with an enzyme. Now there's actually a meeting place, a holding place, that's going to ensure that the simple sugars are bound together. There. And the bond is formed, and off they go.